Assalamualaikum. My name is Siti NURSYUHADA binti Abdul Wahid, and I will explaining about the progress of Chapter 1, which is Process Background and Selection. For the process selection, we suggest three processes of production of propanol, which is direct hydration of propylene, indirect hydration of propylene, and catalytic hydrogenation of acetone. But lastly, we only choose one process to produce the propanol, which is direct hydration of propylene. So for the progress of Chapter 1, basically we have done everything. But we need to redo the process flow diagram PFD, and we check the price and equipment in break-even analysis because there is some changes in the PFD during HASIZ. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL binti Abdul Aziz, and today I will be presenting about site selection, which is Chapter 2. The progress of Chapter 2 is complete, which means we already completed this chapter and already chose the best site for our plan. First of all, the content of this chapter is site selection, selection criteria, overview and comparison, and scoring method. Location is one of the key elements for the construction of chemical plant. In our case, there are three possible sites that have been identified, which is Kerti Industrial Area Terengganu, Tanjung Langat Industrial Estate in Pasir Gudang, Johor, and the last one is Gebeng Industrial Phase 2, Pahang. As for the selection of the site, we select the site based on these criteria. The first one is the availability of raw material, followed by the utility supplies, transportation and accessibility, labor supply, land availability and the cost, environment aspect and safety aspect. And the next is overview and comparison. As we can see from the table, Kerti Industrial Estate is the most cheapest compared to the other two. In terms of the raw material, Gebeng Industrial Estate seems to be the most easiest one to obtain raw material compared to the other two. And in terms of transport facilities, I think the three of them score equally, which means each of them have access to highway, expressway and roads. Besides from the road access, there are also port access and airport access for each of the site that we chosen. For the next part is scoring method. For this part, it shows that Kerti Industrial Area scored the most, which is 370 points of the total score compared to the other two, which means our chosen site to build our chemical plant is Kerti Industrial Area. So in conclusion, the most suitable location is in Kerti Terengganu, as it has higher score compared to the other two sites. Kerti Terengganu is a place that has the best site location as it has more advantages and suitable to produce isopropanol. This location also has a lot of benefit as it is close to other chemical plant production, which can help lower the cost of transportation and safety aspect, which is very important for the capital investment. Moreover, Kerti Industrial Area has the highest score in weightage factor scoring model. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to share about the progress on chapter 3, mass balance. For right now, we already completed, basically the introduction part already be completed, including the theory of mass balance. We already make most of the parts, starting from the introduction to the theory, and also including the methodology itself. And we also include the types of chemical processing, or the process includes in the production, batch process. So we also already included the basis of calculation to produce around 65,000 metric ton per year of isopropanol, and the calculation already been made, and the general assumption of the calculation also already been made. Mass balance on equipment also, actually we already made the mass balance on equipment, referring to a thesis before, but we have several problems regarding to the simulation, so we need to redo the calculation on the mass balance. But for the information, actually we already done most of it, starting from the introduction, okay, mass balance of each equipment, mixer, and then reactor, and then all these things already been done, but just need to be redone to change the value and to change the data. But for now, for the mass balance, I've already proceed on the mass balance on the decision column. I mean, we already separate each of our tasks to do. Every person will get an equipment on the mass balance, and I've already done my part, and my friends also already done their part, but we need time to compile it. That's all for the mass balance chapter 3. Mass balance for
Assalamualaikum, my name is FATINI and I will present on HASIZ. So we have already set up the PFD of our process in the HASIZ, and currently we are working on our report on HASIZ part. So I will explain roughly on the HASIZ. So the fuel package that we have chosen based on the component is an RTL. And for the PFD, we have 4 distillation column, 1 reactor, 3 heat exchanger, 2 pump, and 1 mixer. We also have 2 recycle stream. So the feed for our process are propylene, and propylene from recycle stream, from propylene propane column, also water. The feed will react in the reactor and then will be passed to cooler to be cooled before passed to propylene propane column. In propylene propane column, the unconverted propylene will be purified before passed to the recycle stream. So the bottom product will be sent to the next distillation column, which is the light gas column. So in stream 4, the composition here is the light gas, while the bottom product will be sent to the next DC, which is the isopropanol and water column. In this column, isopropanol will be generated. Okay, as you can see, the mass flow for isopropanol per hour is 8,329 kilogram per hour, which we already calculated, and the yearly production for our product is around 65,000 metric ton. So the bottom product, which contain most which mostly contain water and DMSO. Oh, DMSO from the fourth DC will be sent to the isopropanol water column as an entrainer to separate the isopropanol and water. Okay, so the bottom product will sent to the DMSO water column, and in stream 18, there will be wastewater come out from there, and the bottom product, which is DMSO, will be recycled back to be reused in the isopropanol water column. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, Doctor. My name is FATIN AMIRA and I'll be presenting for the progress of Chapter 4, Energy Balance. Here is the cover page for Chapter 4, Energy Balance. And then here we got table of content, we got introduction, equations for calculation, information for calculation, energy balance of equipment, we got heat exchanger, 3 equipment, reactor for 1 equipment, and distance control, we got 3 equipment, and then there's the reference. Here is the introduction for under theory, and then here got equation for calculation which used in the energy balance calculation, and then here we got information for calculations such as specific heat capacity for at liquid phase, at gas phase, and then we got boiling point, heat vaporization, molecular weight, and heat of formation, which this information was used for calculation in energy balance. Here, energy balance of equipment, we got heat exchanger, 3 equipment, reactor, and distillation column. This one, I'm still waiting for everyone parts to calculate this energy balance for each of these equipment. So the progress is well made, and this is reference. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD FIKRI bin Muhammad YUSOFF. I am going to present on the progress of Chapter 6, which is Waste Management. First, let's go through the content of the slides. In these slides, I will be presenting on our progress, which is Waste Management System, Solid Waste Management, Process and Synthesis Description, Estimation for Waste Treatment Cost, and the Industrial Treatment Effluent System. For Waste Management System, the Environmental Quality Clean Air Regulations 2014 will be used. It is applicable for premise that conducts burning or incineration activity, any industrial plant, premise that discharges air pollutants into the open air, and any fuel burning equipment. Next is the Solid Waste Management. In this part, we have explained the definition of solid waste management, the purpose of solid waste management, and the regulations used, which is Environmental Quality Schedule Waste Regulation 2015. For the process and synthesis description, we use zirconium tungsten as our catalyst. This catalyst is belong to Group X, which is inorganic waste in Quality Alam Waste classification. We also touch on the charge of the solidification treatment, where our waste bulk is around RM765 ringgit. The next part is the estimation for waste treatment cost. After several calculations that have been made, the cost for solidifying treatment is around RM1,262 ringgit 25 cent. The cost for transportation fee is RM371 ringgit and 61 cent, and the total cost is around RM1,633 ringgit 86 cent. The last part is Industrial Effluent Treatment System. In this part, we have explained on the biochemical oxygen demand, total suspended solids, and the chemical oxygen demand. Several calculations were also being made, which is the calculations of fine screening, coagulation and flocculation tank, primary clarifier, aerated lagoon, secondary clarifier, and chemical oxidation. For air pollution, we are still in progress of doing it and will soon be included in the final report.